conservation to pay attention to. Take it away.
So hi everyone, just to quickly introduce ourselves again, my name is Laura Mills and I'm a rising senior studying history and data science at William & Mary. Maeve.
And I'm Maeve Naughton-Rockwell and I'm a rising senior studying data science at William & Mary.
Yeah, so this summer, our research on deforestation monitoring is sponsored by the Institute for Integrative Conservation, also Global Research Institute at William & Mary, and it's also supported by Data Science for Sustainable Development, or DSSD. So today we'll speak about our research aims, progress that we've made so far, but also next steps in terms of creating our end product. So. All right, so when it comes to tracking deforestation, there's a range of remote sensing techniques that can be used, of course, and often accurate deforestation requires sort of a cocktail of a lot of these different techniques. But we decided this summer to sort of narrow in on one, the Breakthrough Additive Season and Trend, or BFAST method, for automated change detection within time series models of satellite data. So say you have, as shown in the time series, 16-day composites of normalized difference vegetation index, or NDVI data. BFAST can be applied to that sort of time series, ones that have variation with seasonality and noise, and then very robustly detect abrupt changes within that time series, but then also characterize magnitude and temporality of those changes. So it's very important in terms of being an early warning sort of flagging system, and we think that can really be transitioned into more of an operational framework for deforestation monitoring. There have been a lot of proof of concepts for BFAST in terms of detecting deforestation, but we wanted to focus on kind of the deliverable end of that. So the crux of our research this summer is to understand a lot of the analytical potential of something like BFAST, but then also understand how to communicate BFAST insights to conservationists, researchers, and other stakeholders that are concerned with deforestation monitoring. So you can do next slide. And we translated this goal into about 3 different prongs. So the first is actually applying the BFAST algorithm for over a wide geographic extent, but also for near real-time insights about deforestation or land degradation in general. So the BFAST is most commonly applied using the R scripting language, but also automated downloading with MODIS NDVI or EVI data. But this is really computationally heavy. It requires a lot of memory and storage. It's not necessarily the most reliable. So we wanted to find the proper platform for doing the type of satellite imagery analysis, meeting the computational needs of ours. And then once we found that, we wanted to transition over to a web application that most importantly has a very simplified user interface. We want users, even the most non-technical of users, to be able to input something and have very simplified parameters for an input, but then also give a very clear output and basically communicate, did deforestation happen in this area or not? And then thirdly, we wanted to identify how we can contribute to ongoing discussion about deforestation monitoring and what our insights with BFAST, something that's been around for a while now, what new insights we can give to people looking to use it. So we can go to the next slide. For our methods, we landed on the platform Google Earth Engine. For those of you who don't know it, it's one of the most powerful cloud computing platforms for geospatial analysis. It has a multi-petabyte catalog of different geospatial data sets and different satellite data. So it was going to be perfect. It was going to meet our computational needs. And also, about a year ago, last August, a paper was published that translated the BFAST monitor from R to JavaScript for re-implementation into Google Earth Engine. So we talked to the authors and got permission to use their code as a baseline for applying BFAST within Google Earth Engine. And from there, we've been building it into our own app, but also adding our own additions to the code and simplifying the user interface. So the data that's used is very similar to NDVI, is the moisture index, and then we're deriving that from Landsat 5, 7, and 8 imagery. And Maeve is going to talk more about Google Earth Engine and where the code has gone.
Yeah, so the code written by the researchers in the implementation of BFAST monitoring paper left off with a layer of pixels shaded by their predicted magnitude of deforestation. The leftmost picture is a screenshot of this output, and the larger square in red is the output of their BFAST code calculated from a Landsat tile, with the pixels representing the magnitude of deforestation detected. The blue rectangle inside that is the region of interest which we are focusing on. We decided that a simpler version of this layer with polygons to show the regions of deforestation would be the best way to visualize the information for conservationists and non-technical people. So from there, we decided on a threshold of magnitude from which to consider a pixel as deforested, and then reclass the raster into a binary with zeros meaning no deforestation detected and ones meaning deforestation was detected. This layer can be seen in the middle photo with the black pixels representing the deforested area. Next, we created a grid across this region of interest. This grid is a feature collection made up of rectangles, each with 1 square kilometer area. Using this grid, we then clip the binary raster of detected deforestation to each of the rectangles, taking the average value per rectangle. And using this final coverage, we can see in the rightmost picture that the detected regions are in red. So each red rectangle represents a 1 square kilometer area where significant deforestation was detected. So next, I'm gonna take you through a demo of what our web app looks like right now. So as you can see, it's a major work in progress, but right now the idea for this application is for the user to choose an area of interest for monitoring, either by clicking on the map to highlight a region or inputting coordinates. Once the user chooses an area of interest, they will then specify the year that they'd like to start their monitoring and what year they'd like to end their monitoring. Once they've chosen the parameters, the app will calculate the BFAST magnitude and find the regions with the most deforestation, displaying a layer like the one showing now. As you can see on the right, there's a really baseline prototype for what the legend might look like for the web application. In the future, we plan to add a lot more options for customization. For example, like a more efficient way to choose years, options to look at the point or polygon data, and different ways to export formats of data for use. All right. Now back to you. So looking forward, we plan to pick a case study to verify the results of our Google Earth Engine app, and then we will fine-tune and simplify our coding and work on the presentation of the web application. We hope to create a fully functional and interactive application providing the information necessary for conservationists, while also being easy to understand for non-technical people. When the web app is finished, we're going to create a website to host the app and give further background information about what BFAST is, how to use the application, and how to interpret the results, like a video on how to use it all. And we hope this will be a resource for people, no matter their technical or GIS skills, to give correct and easy to understand formats of data on the health of forests. Any questions?
Thank you both so much. Please add questions to the Q&A. This is a really important presentation, in part because of the way the Conservation Remote Sensing Network thinks about remote sensing for conservation applications and building capacity around easy-to-use tools and digesting information, rather than trying to be creators of that information, taking data, the satellite image, to that information. So this is really incredible. Do you see there ever being a possibility where you put in your region and it just sends you an alert if something comes up, so you don't have to constantly monitor something like this?
Yeah, not sure exactly the Google Earth how they would do that, but that would definitely be a cool feature to add. But I'm not sure how to implement that myself.
Yeah, and it's been interesting working with Google Earth Engine because we're working within Landsat tiles, and then Maeve specifically. There was a question about our study area. It was basically just a randomly drawn rectangle. We're in Bolivia right now, but that's why we're going to choose a case area and try to verify our results with known facts about deforestation in that area. But in terms of, you kind of were thinking like, could we take a Landsat tile, calculate BFAST at the pixel level within that Landsat tile, and then have it across an entire country? Google Earth Engine doesn't really support that, even though that that's a lot of, that's very computationally demanding. So we're looking at the extent of how far we can get. I know that we talked about in this presentation of introducing BFAST across a very wide geographic extent. For something like using BFAST in R, the most I could do at one time sometimes was like 20 kilometers by 20 kilometers. So there are definitely a lot more room for expanding like a study area, and then also potentially having people draw the boundaries themselves. But I see this as either drawing boundaries if something like Google Earth Engine allows it, or a different platform, or uploading your own type of shapefile with multiple boundaries maybe within an area. Because I think if there are smaller boundaries, BFAST can definitely be calculated sort of within those areas. There's a difference. Sometimes BFAST takes on a spatial subset, sometimes it's at the pixel level. So it's just a matter of, do you take mean NDVI within multiple boundaries, or do you still do it at the pixel level there? I think that's just a question about efficiency later on that we would have to encounter.
Excellent. And a few more questions. One, if this is successful, and I'm confident it will be, have you considered adapting this to other types of land changes, such as loss of wetlands? Excellent question.
That's interesting. I think for this type of change detection, you can really apply any types of satellite imagery and data. So I haven't looked too specific. I don't know, maybe if you have too specifically into wetlands with this and what type of data that would require, but as long as it can be really set into a time series, and there's a quantification of health when it comes to wetlands that can be visualized in a time series, I definitely do think BFAST can be applied there. It's just a matter of determining like what size magnitude would actually translate into potential loss for the different types of data and different types of land that you're using.
And for wetlands, wetlands poses a lot of challenges from a remote sensing perspective, but with the rapid availability of radar data now coming online, there's some potential there. We have time for one more, and then Maeve and Laura, I would encourage you, if you have a few moments, to go through and look to some of the other questions and just try to type answers to them. The last question I'll ask here is, how scalable are your methods? Is there a max area where this is no longer feasible or reasonable?
Yeah, no, and that's something. So right now we're pretty much contained to one Landsat tile. If you do a second Landsat tile, it sort of crashes. So I think we want it to reach farther than a Landsat tile. That's actually way more than I think we both anticipated. But the max scale, we're making adjustments. Maybe you can also talk more about this, adjustments within the code to allow for larger areas. That's sort of what we found at the moment.
Okay. Well, thank you all so much for that presentation. That was really excellent. And based on the questions, a lot of people are eager to follow up with you on this to see if we could apply it to or see if you could apply